Welcome to the QCIS channel, where you get your daily dose of science, technology, engineering, and math. My name is Leon Jones, and what I'm going to present to you all is finished concrete. Now, previously, I shot videos out here when they were placing concrete. However, you never saw concrete once it's finished, once they put the control joints in the concrete. Now, today, I'm going to show you what it looks like. All right, looking down, this is what finished concrete looks like. As you know, it's been formed up. The forms are still there because the concrete is still wet. Now, I'm going to point down to you something. My finger, that's a control joint. Now, what that control joint does is, when you have concrete does two things, and that depends on the season. Concrete during the winter contracts, in the summer it expands. And something else to show you too, so you know exactly what I'm looking at. Part of this sidewalk is also an ADA ramp. Now, this right here is a detectable warning surface. Now, this detectable warning surface has truncated domes. My hand is on a truncated dome. Now, those domes are placed there for a specific reason. When ADA ramps are placed, they must be in compliance with the American Disabilities Association. Now, you have a number of individuals who are handicapped. Now, the ADA ramps are put in place mainly as a ramp for wheelchairs. Now, these detectable warning surfaces, they're put in place for blind people. So if I'm blind, I can feel these domes, touch these domes with my cane or whatever I'm using to get across the street. And these detectable warning surfaces are close to the street. Now, they're close to the street because the closer you get to the street, if you use your hearing, you'll know if there are other vehicles coming along, like bicycles and motorcycles and cars. And you can feel where the street is, or you're near the street, by touching the detectable warning surface. Now, going up here, there's white stuff, or there's white material on this concrete. Now, that white material, they put that white material, it's called curing compound. And after concrete is placed, you want it to cure. Now, generally, if you have good concrete, it can be 60% cured in 7 days. Now, of course, you still have the formwork on the concrete. Now, what are these orange things? Well, these are caps for safety. That's in case somebody steps on these pins. So this is to protect people from stepping on the pin. As you know, in construction, you always have to cover yourself. Now, as I'm walking down the street, this is the sidewalk. Sidewalk already done. Now, looking down, you can see it finished. It's already been broom finished. Now, that broom finish is put in place so people won't slip. Concrete, after it's been placed, once it gets water on it, it can be very slippery, especially in the wintertime. And if you have crossed bridges, you'll see a sign that says, "Bridge freezes before road surface." And they're basically talking about the concrete deck. Now, again, you can see another ADA ramp. And here's what it looks like. And you can see how it slopes. Generally, your ramps should be about 1.5% steep. Now, if you have a landing pad, it should be 8.33%. We go out and measure it with a smart level. And it's very important that we maintain the standards. Now, here's this finished sidewalk after it's been poured all the way down. Now again, I'm going to walk you around, show you some more form work. This is what it looks like after it's been cured. Now they just poured this sidewalk today. Now I'm going to show you a sidewalk after it's been cured. Forms removed. Now here's a concrete sidewalk after everything has been removed. This is the finished product. Now again, let me show you a control joint. Now, this is a control joint right here. It's a piece of corkboard, about a 1/2 inch thick. Just like a bridge, concrete, you must have control joints. Now you can see the finished product, how white it is. It's been cured. Now, these control joints are put in by saw cutting. They're called fakes. And what's supposed to happen in the wintertime, the concrete will crack around these joints if it's frozen. And you can see the finished product, not just on the sidewalk, but on this approach. And something else I want to show you. Here you see all the broom marks. You see it's been broom finished. I'm going right over it. It's rough. You know, you hear that sound when you're on the bridge? They make it rough so the concrete doesn't get slippery. Now, sidewalks don't have as much traffic as actual bridges. However, it's still a path for individuals to walk on. Usually it's low. Now, you're seeing what dry concrete looks like after it's been cured. Let's go back over to the wet concrete. And then I'm going to... Okay. This is what it looks like wet. I think you can show you another truncated dome after it's been poured. Show you what a completed 88 ramp looks like. Now you're seeing the sidewalk as I walk down it. You still see the formwork attached. It's still wet. I'm not going to step on it. Just want to make sure that nobody steps on it. And this is the job of an inspector. I want to make sure that it's been placed properly. Give you another view of what wet concrete looks like after it's been cured. After it's been poured, and you can see the looks like powder. That's called curing compound. Now I'm going to take you over to show you what a completed 88 ramp looks like with the truncated domes. Now in front of me is an 88 ramp, and these are the completed truncated domes. See them sticking up? I got my hand right on the truncated dome. And this is a completed ADA ramp. Now I'm going to be inspecting this very shortly, not today, but in the future. And I'm going to have a smart level, and I'm going to show you how I come up with the percents. Now again, the concrete placement was for sidewalk. And this is not a large area of sidewalk. It's really a small area, one truck. Generally, sidewalk is 4 inches thick, 5 inches wide. So generally, as an inspector, the contractor and I'll get together. We come up with a quantity. We measure the length, the width, and the depth, and we divide it all by 27. Now, 27 means 1 cubic yard equals 27 cubic feet. Now, we measure the sidewalk before it's poured, so we know exactly how much concrete we need to place for this piece of infrastructure. Now, generally, your trucks hold between 8 and 10 cubic yards of concrete. Now, again, it's very important that you look at the concrete right now. The concrete is curing right now. Now, sometimes we would put blankets over the concrete in the winter time, because during the winter months, you have to use winterizing, put some polyurethane plastic. That's what they do in buildings. Or you have to put some blankets. Got to heat it sometimes too. But concrete temperature should always be between 50 and 90 degrees. Again, if it's below 50, you can add accelerator to it. If it's above 50, you add ice. Now, generally, you want your concrete to be poured with a temperature of 70 degrees, because that's in between 50 and 90 degrees. Now, again, you're seeing what finished concrete looks like after it's been poured. The forms are still on this finished concrete because it's not ready to have all the forms pulled off yet, because it's still curing. Now, also, the concrete must be poured within the plans and specifications. Now, something else to tell you as an inspector. Contractors are paid based on a quantity. Now, the quantity is based off of a length, it's based off of volume or area. And then if you have hardware in each item. That's why contracts are unit cost contracts. Now what I'm doing, I'm showing you what the concrete looks like after it's been placed. Giving you a view downward. Showing you another ADA ramp. Now at these ADA ramps, they're going to place crosswalks. And some of your ADA ramps have pedestrian poles, and each pedestrian pole has a button on it that controls the walk or don't walk signal. Standard specifications call for your pedestrian poles to be up about 42 inches. Now, why do they pick 42 inches? Because if somebody's in a wheelchair, 42 inches is not an unreasonable distance to reach. You know, construction is very funny because everything is done via plans and specifications. And again, you're getting this idea of what finished concrete looks like after it's been placed. Right now it's basically setting too. Now, something else that you guys need to look out for if you're going to get in this field of construction is you got to look at the hazards on a job too. You got to look at the grade stakes. You got to look at how everything is placed, because there's some things that we've had to fix on this job. Again, I'm taking you down to concrete that is already cured. Now that concrete in 7 days will be roughly 60% cured. This concrete is 100% cured. Now, normally when it comes to concrete, we take tests on concrete. It's basically up to 50 yards. And the reason why we take tests is we want to see the concrete strength. We want to make sure that we make specimens like cylinders or beams. We want to test for temperature. We want to test for air. We want to test for slump. And then once we test for air, slump, temperature, then we go ahead. That's part of our documentation. Now again, you're looking down at the sidewalk that has not been finished. Already, somebody's ready to step on our sidewalk, and I'm going to have to go rogue out here after the work was done. But that's my job too as an inspector. Show you what's going on here. Show you the hazards. And again, you're getting an idea of what concrete looks like when it's wet. Again, I'm just making sure that nobody walks on it. Give you an idea of what concrete looks like when it is still in curing mode. Now, when we deal with concrete, some of the equipment that we use is very critical when we test it. It has to be calibrated. And if you are in the business of having a concrete lab must be accredited. ASTM, ACI, ISO. Because all of your equipment must be calibrated. And this is what I would tell somebody if they were going to the doctor. If your numbers are reading wrong, you ask your doctor or your nurse or your physician's assistant if the equipment that they're using to take blood pressure or EKG exam is calibrated. The better calibrated your equipment is, the more accurate your readings are going to be, because that's basically what we do out here. I'll take you and show you a little bit of our equipment. So I go into my office here. Because concrete is something that we do pour on jobs. And before we pour concrete, we take tests. I'm going to show you some of the testing forms that we use. All right. Now, before we set foot on any type of placement of concrete, we got to make sure that the soil is correct. So what we do, here's a sheet I have in my hand. That's what we used for the LWD. It's a lightweight deflectometer, and what we utilize with that is we take moisture exams. We want to see if the moisture is meeting the specification requirements. Now, if the moisture is a little bit over, I let it go, and it just depends on how much over it is. Now, this is a little sloppy. I did a test earlier. This is what it looks like. Here are the numbers I got. Now, the required deflection that we want is 0.57. Now, what I did, I took 9 different tests. And each test I got a reading and then an average. So it's a total of 3 tests. Now, based on my own judgment, when the soil was tested, numerically, it did not meet the requirements. So when it doesn't meet the requirements, what is my recommendation? Well, they're going to have to roll it again and add more water and roll it again. Now, if it's just above the requirement, I'll let it go, and I'll say, well, looking at the soil itself, the soil, it's not going to go anywhere. Now, what I was doing was actually testing aggregate. And that aggregate is what you see on the ground. This is called 53 stone. Now, the good thing about 53 stone, it's very easy to compact. You see, it looks sort of like flowable fill. It's very hard. Now, this kind of stone, it's generally not 53. This is number 8 stone. 53 is a little smaller in size. Now, some other items that I'm going to take you around and show you. Let's go to some soil here. I know this video was about concrete, but you need to know what soil you're dealing with too. Now, as we go to the finished sidewalk again, this sidewalk, you look at the soil, and I'm playing with soil. It's very dry. It's crumbly. It's rock mixed in with the soil. Usually when it's dry like this, it's very silty. And because it has a lot of granules in it, like stone, the material is very coarse. Now, some material that is very fine has less voids. It has granules in it, but the granules are very small, like this. This right here is very, very, it's very, very, pick some more up. It's very, very fine material. It's not plastic at all. Plastic material, you can roll up and it looks like Play-Doh. This is more or less silty sand. Now, this sand is what we use when we make beams. Let me show you what a beam looks like after it's been broken. This is a concrete beam right here. Generally, when we have a lot of concrete, now in Indiana we use cylinders sometimes, but they love using beams. Now, this is a beam that's been broken. Now, when the beams are actually made, because beams are basically used for flexural tests, and a flexural test would be if they were using precast concrete beams on bridges. You want to get a compression, because how your beam compresses indicates the strength of your concrete. And you want more of a conical shape, which is known as a shear break, when you break your concrete. Now right here, this is all sand. This is what we use to cover our beams, because your beams should be covered. Since we don't have a curing box, we use beams. Now, for cylinders, we have a curing box. We put a high-low thermometer in it, and we watch the temperature. Something else I'm going to show you. I'm going to show you what an approach is too. You know, a lot of us, when we deal with driveways, how are driveways made? Well, you want to pull up in a driveway off of a street. What you're seeing is an approach. This is an approach. That's what it looks like. And this is an approach that has already been completed. Now, when they put this sidewalk in, they broke this approach, so I had them fix it. So here's what I had them do. Put in a triangular piece. They can feather out to make it blend in. Again, here's some more of your sidewalk, completed sidewalk, and cleanouts. This is for sewage. You can take the top off of this, put an instrument or a snake down it and clean it out. These are cleanouts. It's a piece of PVC pipe. And again, when you're working on construction sites, you got to be thorough. You have to be precise in all of your measurements. And you have to know what you are measuring. But again, let me walk down memory lane for you all to show you what this video was about. It was about the placement of concrete after it's already been finished, cured. You've already had your expansion joints sawed or placed. and you still have your formwork. And this is the sidewalk, what it looks like after it's been poured and finished. Now it's setting, it's curing. This is what it looks like. And part of the sidewalk is your 88 ramp. Again, this is what it looks like after it's been placed. Construction joints and control joints placed, cured, and broom finish. So that concludes today's topic on finished concrete. If you like what I just presented, please comment, share, and subscribe. And if you're looking for some social content, you can always check me out on the 401 Talk Zone radio show as well. Now, if you cannot find me on YouTube, you can always check me out on Twitter. Now, for the QCIS channel, I go one step further since it's an educated channel. You can also look me up on LinkedIn. And again, I thank you for viewing this video on the placement of concrete and what it looks like when it is finished and cured. And of course, I gave you the concrete after they placed it, and it's setting, and I've also shown you what dry concrete looks like. And once again, I thank you for listening to this video on the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. Once again, my name is Leon Jones. Till next time, I want you all to have a wonderful and gracious day.